All right, let's take a look at doing Lab 2D with some recursion. I have already set up a project and I copied and pasted the instructions from over there, but it might be easier to read on the other screen, so I will go back over. It says write two C-type functions that calculate powers x to the n, where x is a real number and n is a positive integer or zero, so non-negative. And we want to have some sort of validation in there to make sure it is non-negative. We do not want to use a math library. No cheating using POW_xn. That's cheating. We're going to come up with a POW iterative and POW recursive function set up to do it. And these are ideas to trigger kind of like how it works. So let's come over and just take a look at setting it up. That's all we really need right now, right? Let's get it working normal in the main, and then we'll make a function out of the iterative process. And then we'll do the same with recursion. Okay, so step one goal. Make an iterative approach to finding x to the n power. So it says we do need a double x and we need an n. That's part of it in there. So we'll definitely have that. Let's start off with one we can easily check. X equals 2. Powers of 2 are well known. 2, 4, 8, 16, 32. Maybe we'll start with let's see, 2, 4, 6, or 2, 4, 8, 16, 32. And if we do n equals 5, we should get 2 to the 5th will give us 32. That's what we're trying to get. So maybe I will create a temp function real quick. And we need it to be a double because it's going to be our outcome. What should we call it? Temp flame. POW iterative. That works. And we'll start it at 0. So an iterative approach means doing like we do start off with x, and then we have x times x, and then we have x times x times x, then we have x times x times x times x, and this keeps going. So we should use a looping structure. We could do a for loop. Print I equals 0. I less than n. I plus plus. So here, what do we want to do in this loop? This will go through n times, which means for this, multiplication. So maybe I'm going to start off with double power iterative equals 1. And now I could just say POW iterative equals POW iterative times x. Does that reason out to what we want? So like for I equals 0, the first effect, yeah, we can run it real easy and find out it's going to work. But like when it doesn't work, being able to write down what's going on with the process is a helpful skill. So we're doing it even though we know it works. For I equals 0, we're going to have 1 equals 1 times x. And so pow iterative, I'll just abbreviate it pi for here, equals x. And then we get I equals 1. We have pi, which is x, equals the current pi, which is x, times another x. So now we have pi is x squared. And so doing 2 should give us, it should keep bumping this up. Because we're just multiplying by another x. And on I equals 5, the loop's dead. Because I is not less than 5. Should work. So like that's like you kind of want to be able to pencil out what's going on just in case shit's not working. This was dumb. It's not going to say shit. I didn't tell it to tell us anything, did I? What did it the other way? No, but it did know it's automatically given the decimal places when we declared it a double. And say, oh wait, x to the n equals, make it pretty, why don't you like that? Let's find out. Scrub. To the power of 5 equals 32. I didn't say to the 5th power because if it's like second or third, it's not a fifth. Okay, so we haven't quite met what we wanted to do even for step 1 because it did say get this where we can read it better. We need to do some sort of validation on the data. So maybe we can throw that in when we put this in a power function. I'm going to copy that. I'm going to put that right here. And I'm going to change the name a little. Well, yeah, that's fine. We'll come to. What do you mean? Well, we're going to make a function out of it. And we are going to copy that in there. Keeping the same name on the variable was convenient here. We do need pow iter in here for it to work. And now we need to tell it to return pow iter. So we can come up here, we can get rid of that. We did that. Now all we're doing is calling on it. Pow iterative. It takes in X and N. So this is just returning a number. I have the option of saying double temp equals that and putting temp here. Or if I don't need it to use it anywhere but here, I can do that. So I'm going to make a little comment here. This line is only necessary if you want to use the results for other stuff. Like that way you got the value stored. You don't need to call on it, tell it to do the calculations over and over and over. All right, so we've got power iterative going, but we don't have any valid or data validation. So what was the data validation we wanted to do? N needs to be a positive integer or 0. So we need to make sure N is positive. So maybe in here, we'll do that here. Let's do our data validation, verifying N is greater than or equal to 0. How can I do that? What? Okay, so like, this is what I'm hearing. Like if we had N cubed, we know it's going to be negative. So divide by a negative. And for something like N to the 4th, we know it's going to be positive. So leave the sign alone. Oh. So like if this is -3, we can do 1 divided by our result. So yeah, so what is that as Juan is saying? So we need a conditional to check for this. Because that's N to the -3 does do that. So if we had, let's look at this real quick. So the idea here is N to the -3 equals 1 over N cubed. So if we take our results and do 1 over N to the -3, we've got 1 over N cubed. And when you rationalize, or you get rid of the complex fraction, you get N cubed over 1, which is just N cubed. And we've addressed having a negative exponent. That's one way of doing it. Okay. Anybody else like that, or will anybody else want to do anything different? Anybody that's a student, not like an SI? Doesn't it seem fucking easier? Juan's got, he's like over here working with complex fractions and doing the whole math shit. But let's try both. N is less than 0. N equals -1 times N. Right? So what's your name? Evan. Evan's approach. Did I spell that right? Good. Hold on, let me do Juan's approach and we'll comment one out. We'll try them both. We'll do. Oh, we can't do it here. I gotta do it down below, kind of like below. Or here. You want to do it afterwards or during the for loop? But where does the fraction part come in with what Evan said? His completely bypasses. It just says N is -3. No. N equals 3. N to the third. It says fuck off negative sign. That's all it did. Yours is like doing the math shit. He's saying do make a fraction. This was Evan, and Juan's was Juan. Was this what you were saying, Juan? You're saying a fraction. Where's the fucking fraction coming if not like that? I don't understand what you show me on the right on the board what you're talking about. Because that's the only fraction way I can see that what you're talking about. Because otherwise you just talking crazy. Hey, that's fine.
Then we'll make it so that we'll multiply by -1, like inside the middle, this is all multiply by -1. We're gonna put it inside of the fraction, and then see how it does an actual decimal. One divided by.
Again, so where's the fraction part? I don't like. We're multiplying by -1. Where's the fraction part coming in?
Like, let's say
you're glossing over the shit I don't understand. This is the problem here.
Okay, now, let's say that is x, comma, because this is the number. And we'll just put -1 times whatever number that is. Like
okay, so you want to do the del, but where's the fraction part coming in that you're talking about?
I'm just saying that fraction. It's just
right.
This number is positive. No, I have a fraction. So the n is the power, right?
Yeah. What I think you're going for, Juan, is like, let's not get rid of the negative numbers. Let's just come up with a solution for it. Okay, let's do that second. I like that. That's not what the prompt said to do, but let's do that next.
Divided by n squared, so like the n's cancel, but you still have 1 over n.
Why would we do that? But that's more operations. We don't want to multiply by n and then divide by n squared. That's just more work for the computer. We could just divide by n. So as it is, it just wants us to do it, make sure it's not negative. Juan's recommending let's fucking allow negatives. Yeah, so like we'll add a negative feature to it, but I don't know if that's going to work with recursive. So let's just stick with positive for now, because I think that's going to fuck up recursion. Oh, that's in the main. So that, right, but it's all in the main. And the idea was to make a function. So how does that go in? So we got to look at, okay. So Juan said, I don't give a shit what you've got for your project that with the fucking lab 2D. Juan said lab 2D can go fuck itself. We're going to allow negative numbers. So your approach is good, but we can't do it as a single function. Well, it's going to return a decimal.
No, this is the whole thing. Only doing the same one divided by this double. We're just saying what the answer is. The whole time is -1.
But if we put that in the function, now it's like you tend to not want C outs in a calculation function.
This would be a function calling it.
All right.
Okay.
All right. So we'll do that. Okay. So let's make sure this, did that work? Let's just check it here. I'm gonna say n equals -5, and we should still get 32, right? If we did our little switch. Oh, that's just with my C out. Okay, so now Juan is saying, I don't know that it needs a return if we're just doing C outs in it. Void neg exponent checker. What?
This just format for it to make it for positive effect. It does all of it in one. I feel like
Are you wanting me to put a C out down here? That's what I'm about to do. Just fucking wait for it. Still needs to take double X, double N. Or N. Okay, so Juan is saying, maybe I don't know, print power. Let's call it that. Because that's what we're really doing, right? Print power. This is a good addition. I like this. This is a good addition. So we're definitely going to want to call this function up here. I'm just going to go grab it and copy and paste. And I'll use it in a second. Ah, shit. So Juan's saying if n is less than 0, what we're going to do is, I guess I could do the POW iterative ahead of time. Because this got the data validation in it. So I'm going to say something like double temp equals POW iterative. So it gets the value. And then if n is less than 0, we're going to do, I guess I need to do C out. I can, but in here it's making it positive. No, this isn't a power function. No. This will give us like, if Don't make me come over there. X to the power n equals 1 divided by, where's my main? We're gonna get rid of that. We're gonna say print power x to the x comma n. Is that what you want? Is that what you wanted it to say? Okay, so like I did it differently than you had in your head, but I accomplished what you were saying, right? And now we can add in Carlos's bit, else all right, so oh wait, that's my good program. I don't want to fuck with that. I need to do this. I need my barrier. I don't know about you, but fucking finding where the main ends is a pain in the ass. There you go. Now when I'm scrolling, the big old block pops up. It's easier to spot. Okay, so what? No, I didn't. Why would I say bald spot? Let's change n to equal 5 and rerun it. Now it should do both versions. Bam. I like it. Okay, so now we did do the data validation, so we met the requirements of lab 2D for the POW iterative. Now we want to take a look at doing recursion. And this is our recursion tip. So let's try doing a recursive method here. Recursive method, let's see. They wanted us to call it that. And I'll come down here and we'll make another one down here. Now for recursion, we need a base case that stops the program. And it was recommending using x to the 0 equals 1 and x to the n equals x times x to the n minus 1. So kind of like the base case, addressing the base case, if n equals 0, return 1. So maybe I need to make a temp variable here. Not even going to make it if it's already n equals 0. So we'll say, nope, we're doing double. And so what we want this to do is we want it to do this. So we need to do let's just say temp equals X. And then temp equals temp times, if we're doing recursion, that should do, oh wait. There we go. Times pow recursive. There we go. So this is modeling that. Put that up above. I think. Let's do a little recursive trace here. Oh, that's Discord, whatever that is. Probably Juan talking shit in his SI channel about how Jones ain't listening to what he's trying to say. Can't fucking follow instructions or some shit. All right. So we're going to do our recursive trace. And we're looking at x equals 2, n equals 5. So if you watch the other video, like I like to go downward on the page. If you've seen this with Redden likes to go upwards. But that, like, you never know. Sometimes you don't have enough room. Who starts at the fucking bottom of the page? Not I. Americans don't start there. We start in the upper left. That's what we do. That's right. So we're going to do that here. In fact, I'm going to flip this over so that I can do this a little bit easier because the way I have the camera set up. So I'm just going to abbreviate it PR. We're doing x equals 2, n equals 5. So when we do that call, what does it do? It comes over here and does that. So we have x equals 2, n equals 5. And it goes, does n equal 1 or does n equal 0? No. And then it says temp equals temp times, I guess I didn't make my box big enough, PR 2 comma 1 lower would be 4. I don't have a return in there. Okay, now this one triggers the next event. I'll make my box a little bit bigger. X equals 2, n equals 4, n does not equal 0. So we're skipping the base case. We're going to do temp equals temp times PR. We're passing in 2, and n is going to be 1 lower, so n minus 1 will be 3. We got x equals 2, n equals 3. N does not equal 0. I'm just going to say t equals t times, because I'm tired of writing temp. That should be 2 there, not x. And then this one is passing 3 minus 1 is 2. Triggers the next case. N does not equal 0. So t equals t times PR of 2 comma 1. We're almost there. We only got 2 more cases. N does not equal 0. T equals t times PR of 2 comma 0. Finally, we get to the top of the stack, top of the heap. We got x equals 2, n equals 0, and does equal 0. Checkmate, return 1. Okay, so we return 1. This is now t equals t times 1. And then we had a return. So this gets returned up into that bad boy. And we get t equals t times t. And we return that up into that bad boy. And we get t equals t times, I'm going to start just doing abbreviating what the previous line was. Here we get t equals t times t cubed. I'm off screen. That gets returned up here. We get t equals t times t to the 4th. Which is t to the 5th. Oh, wait. It's not t. Is it? Where'd my 2 go? Two never showed up. This should not, but see, this is showing me I did that shit wrong. That should be an x. Right? I got t to the 5th. That doesn't make no sense. So now I can like change that. That'll be t equals 2 times 1. This is t equals 2 times the previous 2. This is 2 times the previous value is 4, which is 8. It's returning 8. This is t equals 2 times 8, which is 16. It's returning 16. And t equals 2 times 16 is 32. And now we have return t at the end there, which is now 32. That triggers and takes 32 back to the main. That's how that was going to work. That's how this should work. So maybe if we want to use this thing, we need to throw in a, oh, do we have any data validation? Is there a way to do data validation there? Let's worry about the data validation in a second. Let's just come up here and do cout, end line, end line. And now we're going to do cout. Let's come grab that line right here. I don't want to type it again. I'm going to grab that and just edit what it says. We're in the main. We're going to say, make that say pow recursive. So here it's doing n equals 5. Let's see if it works. Please work. Good. Now, what would have happened had I just left this as temp, which is what I had initially wrote it as? Does it give us the same thing? Yeah, it does. Okay. I guess because I said temp equals 2, so yeah, it's doing the same thing. So temp would have worked there, or X would have worked there. Temp is actually probably the better choice. That way it looks more recursive. So can we do data validation here? before we let Juan introduce a couple ideas, does anyone else have an idea of how we can introduce negative integers into this? What do you want to do with the if statement? I need a little more than that. Well, let's see if Carlos has got some here.
Negative. And then you say, if you want to add a negative, what negative would you want? And make it, if they say, you know, because we can make it Boolean, so.
Well, that's not something we can do in Power Recursive. We don't want to prompt users for shit. And this is just a function that calculates an answer. So keep that in mind. I know a lot of students, especially from CSCI 1, you want to try to like put all, I've seen like literally the main be fucking empty other than the function call. And then the entire function does everything, which is defeats the purpose of it. Function should do one thing. In this case, calculate a result, return the result. That way it can be used as is for anything. And then if you want to do a C out, have the C out in the main. If you want to prompt for user stuff, do that in the main. Let's just make this a calculation. So with that in mind, can we do something that allows a negative here? Not always get a negative, like, but if n comes in, okay, this, let me. What do we do if n comes in with n less than 0? That's the question. We don't want to force something to always be negative or anything like that, because that makes the positive numbers negative and that defeats the purpose.
From the given if statement, and making it if it's smaller than -1, make it this right.
So just do the regular thing that we had in the other one. If n is less than 0, so this is Carlos. Well, recursion works differently than iterative. This will do it. We would need a separate print function for it. What do you have in mind, Juan? Well, I'm trying to follow the rules of the lab first. The lab is because it should work correctly. Like if I don't put the data validation in here, someone can't grab it and do plug and play later on with it. Make the function right the first time so that it does shit right there. And if we don't, if I don't have this with n less than 0, n equals -1 times n, the double it's going to return is a decimal point. It's going to have 1/2⁵, 1 divided by 32 as a decimal, which is fine if that's what we want to allow. But so what I'm hearing from Juan is let's make a print power recursive. Well, then it doesn't show your pretty stuff like this. Quit fucking doing that, you piece of shit computer. Okay, what? So x to the power is -1 times n. I am not changing the function though. Oops. Because this is a different function that someone else. The idea is like if you're using it and you're working with someone else, this thing should work correctly as is. And if they don't have this print power recursive, and I don't have the data validation here on line 71, and they try to send in a negative exponent, this shit breaks. I'll show it that it breaks. Right. Watch what happens if we don't have the data validation in power recursive without using the print power recursive. Because someone should be able to just grab it and use it, and it's like, nope. Fucking la-di-da, do-do-do, do-do-do. How long should I wait? This program shouldn't take that long to calculate it, and it's not going to work. Stop. So having that common, like we need that in there for someone that wants to use power recursive as is, because we can't assume that they're going to use the print power recursive function. So they may just want to use it for like regular shit and accidentally type in a negative. We got to make sure that this works, but I like having this in the print stuff. I like having that there because then you're like, I don't know whoever wrote the code if they've addressed the negative. So I'm just going to address the negative myself. And we can come up here and do in the main. We're going to check. We're going to do print power. And then I changed X or nen to be negative again. And we're going to do that. I'm going to comment out that line. And now we should get the magic we want. No. Oh, it told me to fuck off. Where? It will. Tells me it's fucking up on line 41 and 43. Identifier not found on character 2. What? Oh, I didn't do the prototype. I normally do it the other way and put the thing up above first, but I was already there and I didn't want to scroll up and do it. Now it should work. Bam. So now we not only did we do what the lab required us to do, because like on the test, you want to make Hefe happy and do what he says, not just wing your own shit. If you want to do more, that's fine, but make it in addition to what the instructions say for the test. All right, so we did that. Let's come back over here. Okay, I'm going to comment that out. I know we can leave it there. So the other part that you need to work on here is like working with arrays. If you look in the modules for lab 2, we want you to start thinking about how you can deal with arrays. And this is really just like, this is like looking at the problem of working with arrays. Trying to delete something. Here it says, having something that deletes an element where you pass in the array, you tell it what array block to delete, and of course with arrays you got to pass size. We'll ignore the T star for now, do pointers and templating later. And we're not going to have time to do it all. The other one has you looking at merging two arrays. In fact, I think I started to talk about this one in the other one. So maybe we can start talking about how we would merge these two arrays. How could we merge two arrays? So what about merging two arrays? So I'm going to say int size 1 equals 3. Int size 2 equals 4. That way we got arrays of different sizes. We'll say array 1 equals, let's call it 1, 2, 3. I'm doing this wrong. There we go. We'll say int array 2, 4, 5, 6, 7. Interesting that it added that spacing there. Huh. So goal, merge these two. And what does that mean even? Put array 2 at the end of array 1. Does it mean put them in order if they're not in order? Let's do that. Let's change this to be the even elements. And let's make this the odd elements. Ooh. That looks weird. Let's take a look at doing the first one first. What can we do here? So I could say, well, let's make int size m for merge equal size 1 plus size 2. That way, if I decide to change the size of the arrays later, we can do that. And let's have int array 3 be size m. So this should be an array of size 7, right? I don't know. Look at that. Bam. Just make sure that's working so far. Okay, that's working. Didn't do anything new yet. So if we're wanting to just I need that either way, so I'm going to put this after that. So if we want to put the array 2 at the end of array 1, this should be kind of easy. I can say for int I equals 0, I less than size 1, I plus plus, array 3 I equals array 1 I. That part's the easy part. Now we got to think about what's going on down here. I'm going to repeat this. I'm going to say size 2 here. And we're working with array 2. Can I say I plus size 2? So the first one it'll put in is 0 plus 4. It'll go in array block 4. No. Because if we look at the camera here, so right now array 3 has, it's got, let's see, we got 7 blocks here. 1, 2, 3, 4, 5, 6, 7. All right, our first for loop put in the even numbers 2, 4, 6. That is in cell 0, 1, and 2. So if I say I plus size 2 for my second loop, this is 0 plus 4. It's going to put it here. So I don't want size 2. I want size 2 minus 1. Does that track? But we're not as, what if we change the sizes of the array? I don't want to do that. If size 1 is 3 and size 2 is like 10, I don't want this to reference size 1. Alternatively, we could say array 3 is size 1 plus I. Equals array 2I. So this one, size 1 is 3. Nope, I still need to do my, nope, because we're starting at 0. 3 plus 0 does work. So this should work. We'll test both. Wanted to just comment that out. And rather than, okay, we'll make a whole nother for loop real quick. Or int, let's change it up. J equals 0, J less than size M, J plus plus. See out the, or element J equals array 3J. Okay, I'm gonna copy this below my recursion shit real quick too. So this should just print out the element. And it did them in the order that I had them. So that's one approach of merging the two arrays. Let's comment that out and see if this one still works, gets us the same thing. Okay, that's good. Now let's take a look at trying to figure out, like, maybe we didn't want that. Maybe we wanted them in order. So how could I do this? Does it mean put them in order if they're not in order? Any ideas? So we definitely got to go through size M steps. And I think trying to do it any other way is going to be kind of hard. For n I equals 0, I less than size M, I plus plus. Maybe I'm going to make a little, I don't know, temp counter. Temp 1, temp 2. Temp 1 equals 0. Temp 2 equals 0. So we got to check which one's smaller, right? We want the smaller one put first. So let's make a little note if that's what we're doing here. Put smaller element first. So I'm going to say if array 1 bracket, I'm going to go with temp 1 here, is less than array 2, temp 2. Now that's just checking 0, 0. We wanted to put array 3I needs to equal the smaller one. So it needs to equal that. Right? And then we could increment temp 1. That way, next time it goes to the loop, it doesn't check the first square again. And then we need an else. And this is just going to be something similar down to just changing this to 2. And temp 2. Is this going to cause a problem when we get to the end of the road? I think so. I think it's going to cause a problem. But we'll look at addressing that in a second. Let me copy my for loop again. Wait, this needs to go after the for loop. And you know what? Maybe I'm going to make this array 4. Because make a new array. We've already done array 3. I don't want to fuck with array 3 again. So I'm going to say, come up here and make bring that down here. And array 4 is size M. And now we're seeing out array 4. Okay. I think this is going to cause a problem when it gets to the end. I did. So maybe we got to add some validation or some checks in here. We got to make sure if R1 temp 1 equals size 1. What's the or? It's the double pipes, right? Or array 2 temp2 equals size2, we got to do something else. Let's just break this down in here. Why doesn't it like that? Oh. Doing a comparison operator is the double equal. All right, now we need another one. Now we're going to break it down. Or we could just do them as, yeah, that was a good practice in remembering what that is. Array1, temp1 equals size1. We'll address that here. So if that's the case, we're done with all of array1. We're just doing array3, right? Or array2. We should be just doing that. Because we're not checking for an if then. We're not using array1 anymore. Array1's dead to us. And I can say else. I don't even need the other if, because if we have the or up here, I'll just go grab this one right here and put that right there. And then we'll slap an else here. I have a what? Yeah, that's cheating. We're doing sort stuff later. The idea was to like practice using, like thinking with the stuff like this, because you're not always going to have a function that's predefined, right? You got to build the algorithm. I like where you're going with it though, Irving. Will this work? So this checks if either one of them is equal to the size. If it is equal to the size, if the first array is done, we don't use the first array anymore. Or, but if that's not the case, that means the second array is done. And we're using the first array. I think this will get it for us. And then we have our else if off of this one saying, okay, this is our normal stuff. I had to do this before because I wanted to check before, right? If I tried to do it after, this one was always going to work. I think this might work. I hope so, because I got 2 minutes left. Motherfucker! Didn't work. Okay, so it's the last element isn't working. When we get to down to the after they've both gone 3, we are done with array 1. So array 2 should be grabbing that element right there. So we're done with array 1. It should be doing this. So this is the fun way to do checks. Just fucking throwing a C out. Debug your shit. Put different things so you know what it is. Good opportunity to check debugging here, right? What the fuck? Didn't even do it. Didn't go to either one. Oh, I know the problem here. I'm checking array size. I need to check if temp one equals. That's the fucking problem. Checking the wrong things. Got it. And it's 6 o'clock on the nose. All right. So I'll copy and put this up later tonight. Well, no, it might be tomorrow morning. I don't know if I'm going to go home and use the computer tonight. Ah, fuck it. I can copy it all right now, right? Control Alt C. Let's come over here. Not that one. Right? Got lucky. You don't always catch your error that quick, right? Tom Cruise. That's a recursion for power or exponents. When it's done downloading and uploading on YouTube, it takes some time. It'll probably be tomorrow morning. You too. That's a good idea. You better not touch my fucking tea. Fuck. Gotta get out of here too. All right, stop share.